Okay, so our next lesson, we're going to talk about how to find trig functions at a point in the coordinate plane. Okay, in order to do this, we need to review. So there are three basic trig functions you learned in Math 2, and we have covered again in Math 3, and we can remember those three basic trig functions using the acronym SOHCAHTOA. Okay, so sine of theta is opposite over hypotenuse. Okay, that's our first one. Cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. I always do that. Okay, opposite over adjacent. Now, there's also three reciprocal functions, and I introduced them briefly to you in Math 2 last year, and we encountered them a little bit more in Math 3 and Calculus, but again, you really just need to know which ones they are the reciprocals of, okay? So the three reciprocal functions, the reciprocal of sine is cosecant, okay, which is abbreviated as CSC of theta, and because it is a reciprocal, it's literally going to be this ratio flipped over. So this is going to be hypotenuse over opposite. The reciprocal of cosine is secant, okay, which we abbreviate SEC, and this is going to be the reciprocal of cosine, which is going to be hypotenuse over adjacent. And then the reciprocal of tangent is cotangent, which we abbreviate COT. We don't say it cot, we still say cotangent, we still say secant, we still say cosecant, okay, of theta equals adjacent over opposite. Okay, so we've got to have those six trig functions. But again, if you know these three, then here you just need to remember that cosecant goes with sine, secant goes with cosine, cotangent goes with tangent. I always remember that the S doesn't match up to the S. Okay, so S and C and S, that's how the reciprocals are related for those two. And then tangent obviously is cotangent. Okay, so if I asked you to find the trig values for this triangle, I want all six trig values, okay? Theta here is going to be my angle of reference, so I need to know which side is the opposite, the adjacent, and the hypotenuse, okay? So we always label opposite first, so I know this 3 over here is going to be the opposite. The hypotenuse is always opposite the 90-degree angle, and then by elimination, this one's the adjacent, okay? So if I ask you to find sine of theta, sine is going to be 3 over 9 opposite over hypotenuse, which is going to be 1/3. If I ask you to find cosine of theta, cosine is going to be 6√3 adjacent over hypotenuse. 3 goes into that 2 times, 3 goes into this time, so it's going to be 2√3 over 3. So there's my cosine value. Tangent of theta is going to be opposite over adjacent, 6√3, okay, which here is going to reduce to 1 over 2√3, which we know we're not allowed to keep, so we have to rationalize. Remember, you only need to multiply top and bottom by the radical, not the 2. So this is going to be √3. This 2 is going to stay. The √3 times √3 gives me 3. So this becomes √3 over 6. Okay, so tangent of theta is going to equal that. But now I want to find the other three trig ratios as well. So that's going to be the reciprocals of all of those. So cosecant of theta is going to equal 3 over 1. Secant of theta is going to be 3 over 2√3, which would need to be rationalized. So 3√3 over, this is going to give me 6 again. This is going to reduce, so √3 over 2. And then cotangent of theta would be 6 over √3, which is going to equal 6√3 over 3, which would be 2√3. Okay, so when you have a triangle and you know all the side lengths, finding all six trig functions is very easy. But what happens if I'm just given a point in the coordinate plane? Okay, so if I want to find the trig ratios in the coordinate plane and I'm just given a point, okay, this is really easy if I know the distance from the origin to this point and I know the angle that has been turned. Okay, so think about if this was in the unit circle, okay, and I said that this angle right here was pi over 6, then you would know that this was √3 over 2, this was a half, and then I could find all of the trig ratios very easily. But if I don't know this angle, okay, And all I have is this point right here. Well, I do know that this is going to be the ray of my angle. And so what I'm going to do is I'm going to draw in a triangle, okay, and create a right triangle so that I can use the values of the opposite, adjacent, and hypotenuse to figure out my trig ratios, okay? So we're going to call this distance right here is going to be x, because this is literally what the x coordinate of my point would be. This distance right here is going to be y, because this would be the y coordinate of my point. And then we're going to call this h for the hypotenuse. So now if I ask you to find sine of theta, sine is opposite over hypotenuse, so sine would be y over h, okay? Cosine of theta is going to be adjacent over hypotenuse, so that's going to be x over h. Tangent of theta is going to be opposite over adjacent, which is y over x, which, hey, guess what? Didn't we talk about that in the last lesson? Okay, and then cosecant of theta is going to be the reciprocal of sine, so that's going to be h over y. Secant of theta is going to be h over x, the reciprocal of cosine. Cotangent of theta is going to be x over y. Okay, so I can also think of these 6 trig ratios as values of x and y and the hypotenuse in a triangle if I just draw the triangle. Okay, so here's an example. So we have an angle theta that goes through the given point. Find all 6 trig functions associated with theta. Okay, so the point that I'm given is 3, -4. So first thing I need to do is graph this in the coordinate plane. Okay, so we know that 3, -4, 3, -4 would be down here in quadrant 4. Okay, so 3, -4. And so I don't know what angle that is going to be if I draw this in, but I do know that I can draw a right triangle here, okay, and I can figure out what the side lengths of the triangle are, so I can figure out those 6 trig functions. All right, so obviously if this is at the point 3, -4, then this has to be 3 and this has to be -4. So in order to find the missing side length of my triangle, I have to use Pythagorean's theorem. Okay, so a squared plus b squared equals c squared. So this is going to be a, this would be b, doesn't really matter, but I do know that I'm solving for c, which is the hypotenuse. Okay, so 9 plus 16 equals c squared, 25 equals c squared, so c is going to equal 5. All right, so there is my hypotenuse. Okay, so now that I have that as my triangle, I can figure out my trig function. Okay, so here's my angle, theta. Theta will always be formed by the hypotenuse and the x-axis. Okay, so if I'm looking at theta, this is going to be my opposite side, this is going to be my adjacent side, and this is going to be my hypotenuse. All right, so sine of theta is going to be opposite over hypotenuse, so -4 over 5. Cosine of theta is going to be adjacent over hypotenuse, so that's going to be 3 over 5. Tangent of theta is going to be opposite over adjacent, which would be -3 over 4. Okay, now something to consider here. Remember, all students take calculus. When I'm in quadrant 4, the only trig ratio that should be positive is cosine. You see how that happens. So sine ends up being negative, tangent ends up being negative because of this -4. So that's why it's important for you to correctly graph where the point is, because then that negative value will be included in all of your ratios. Now, if I want to find the other 3, cosecant is the reciprocal of sine, so cosecant is going to be 5 over -4. You can leave the negative in the denominator, not a big deal. Secant of theta is going to be 5 over 3, okay, and cotangent of theta is going to be 3 over -4, okay, easy peasy. Okay, and then for our last example, what if we have the point 0, -3? Okay, so again, I need to graph that. So 0, -3 would be down here. Okay, and if you are looking at the ray that this angle forms, it's actually on the y-axis. So I can't draw anything to the x-axis. I can't even form a triangle here. Okay, so instead, I really need to think about this in terms of x and y and h. Okay, so if I ask you, what is sine of theta? Okay, here's my theta. Well, we know that sine is really the y value of any coordinate that where it hits in the coordinate plane. So sine is actually going to just be equal to -3. Okay, so again, I can't draw a triangle. This angle isn't swept away from the axes. It's on the axes. So this is the y value, the sine value. Think of that. This is kind of like at 3 pi over 2, right, in the unit circle. So if I ask you what sine of 3 pi over 2, you would tell me the y value at that coordinate. Okay, what is cosine of theta? Well, cosine is the x value of that coordinate, so cosine is going to be equal to 0. And if I ask you what tangent of theta is, you need to think of this in terms of slope. So tangent of a vertical line is undefined, which it would be as well if I thought about this angle, excuse me, at 3 pi over 2. Okay, so there's those three. Then I want my reciprocals. So the reciprocal of -3 is -1/3. And the reciprocal of 0 is 1/0, which is undefined. Okay. And the reciprocal of undefined is 0. Okay, so think about undefined means I'd have something like 1/0. Well, if I flip that over, that would be 0/1, which would be 0. Okay, same thing here. 0 can be thought about 0/1. So when I flip that over, I get 1/0, and that's how I get undefined here. Okay, so if my point lands on one of the axes, you really need to think about it in terms of the x and the y values, and then you can do the reciprocals.